Okay. So if you are able to see it till 25, as I said, you have a proper normal vision. So this is for a normal eye who does not has any, for a person who does not have any defect. So this 25 centimeter is important for us when we do some basic calculation, very simple questions we have from this. So this is called as the least distance. You can write this down. It's called as the least distance of distant vision. Okay, for a normal eye, if you want, you can just write for a normal eye. So anytime it's asked what's the least distance of a distinct vision for a normal eye, the answer is 25 centimeter. Okay, so if you try to bring that object close, it will start straining your eyes and you will not be able to see it very well. And then that range is not considered as your least distance. Least distance means from where you actually start to see the object very clearly. So that is 25 centimeter. That is only for normal eye. You can always check what is your individual least distance. For every person, it might be slightly different. Maybe for some it is 30 centimeter. For some, it might be little beyond it. So if it is beyond 25, that means you do have some issues with your eye. So you can always try that what is the good position that where your eyes are not straining and you're able to read the content of whatever textbook you're referring, whatever book you're referring, you can read it, and that vision is easy for you and it's not giving you any sort of headache. Then that is the least distance for your eyes. Now the problem starts when there is issues with the eyesight. Now that totally depends on a lot of factors. Some defects are by birth due to the bulginess of the eyeballs, maybe something related to the cornea, maybe something related to the ciliary muscles, which helps in holding up the eye lens. Okay, if they get loosened out or if they are too stiff, a lot of factors, as I said, is the reason for an eye defect. Okay, so the size of image is always to be formed on the retina. Whatever image you're going to have, images are always formed on retina. You can write the next line. Images are always formed on the retina of the eye. Okay, so retina is almost at the back end of the eye. Okay, let's say this portion, the blue portion. Now suppose there is some object and rays are traveling through the eye, and let's say they have been, you know, I will tell you what type of lens our eye is naturally, and let's say they have got intersected in such a way, and you see that the image is formed much behind the retina, then that is a problem. Let's say in some situation, due to the way the it is converging, the rays are formed in front of the retina, maybe here. So not exactly on the retina. So there are two situations. One, the image is behind the retina, and the other is it is formed in front of the retina. In both the cases, there is some kind of defect because the image is always supposed to form on the retina. Okay, so this is important idea whenever we discuss the defect. So you may write the next point. The size of an image on the retina is actually determined by the angle subtended by the object at the eye. Okay, that is done. Now, this angle plays a very important role. And the condition is if this angle is very small, smaller the angle, smaller the object. Because what we have said, the size of that image will totally depend on this angle subtended. If this angle is very small, then the size of the image will also be very small. Okay. So if image size is very small, you'll not be able to see it. The eyes are not able to see that object. Now, what is the condition for normal situation? If any time this angle subtended is less than, these conditions are important for the MCQ purpose. If it is less than 1 minute, 1 minute here is something related to your radians degree value. So this is the way we represent minute. See, one is degree, dash is minute, and double dash that you see on a number, let's say 18 degree, 46 dash means a minute, and let's say 23 with a double dash, it's a second. This is how you read. This is not time. This is related to angle. Minutes and second, though it has the same terms with time constant, but here it means angle. Okay, so if you want, you can write it degree. This is read as minute, and this is seconds. So anytime if the angle is formed and that angle is less than 1 minute, and 1 minute is technically equal to 1 by 60 degree. So if we have 60-degree angle and I divide all the 60-degree into sections, one part of it will be called as 1 minute. So if the angle subtended is less than 1 minute, we will require an additional support to help view that object. And that is always going to be a convex lens. We need a convex lens. And this convex lens has a particular requirement. This convex lens has to be of a short focal length. Done writing all this information, everyone? Finish writing? Is there anyone who's still writing any point? Yeah. So what we need a convex lens, and the condition is this convex lens should have a very short focal length. Short focal length. This kind of object, if we're able to make, that object will help us to get a very magnified view of an, sorry, this lens, if we get a magnified view. So first thing, we get a magnified view. Second thing, we will, because we're using convex lens, in that case, we are getting an erect image. And if it is an erect image, it is going to be virtual. These three conditions are perfect to satisfy the need of a magnifying glass. And that is what a magnifying glass is. So what is a magnifying glass? Also called as a simple microscope. Some cases it is also called as reading glasses. Okay, for people who, like, after a certain age also, maybe due to whatever factors, they are not able to see or view or read even books which is close to them, they need glasses. And you see older people, when they want to read any content, they need their spectacles. So these spectacles are particularly made up of convex lens. So convex lens which has a short focal length, that's a condition, gives a magnified view of erect and virtual image, also called as the reading glass, is nothing but magnifying glass. So if they ask you what is a magnifying glass, which type of lens it is, so it is a convex lens. Okay, that's going to be a convex lens. So the idea is that this magnified image that we are going to have, this will always help in subtending an angle which will be greater than 1 minute. all MCQ questions I'm picking up that can be possibly asked. Okay, so two things we get to know: magnifying glass, which type of lens it use, convex lens. Second situation, it is going to subtend how much degree angle. It's going to have an angle which is greater than 1 minute, and that will help us to see objects very clearly. That's going to help our eye. Maybe your eye is not having any issue, but you are trying to view an object which is very tiny. You want to check it more clearly. So in that case, also you can use a magnifying glass. Using a magnifying glass does not directly tells that you have some defect in your eyes. In a lot of cases, like in the forensic science, when the thing that we deal with, that they are all using these, does not mean they might be really having some vision related problem. But just to have a better view, we can use it. Yes, finish writing, everybody. Now we write simple construction based on it. So a diagram can be asked just on that place. You can always have a convex lens, and short focal length means little bulgy it is going to be. And you will have some frame attached to it. Frame you can always put dash, and you may have a holder. This is going to be the holder. This is going to be the lens, and we know it's the kind of convex lens. Finish writing, everyone. It's reconstructing the diagram. Okay. Now the next thing quickly we'll see is the magnifying power. This power and the lens combination power has a difference in the formula, so be very careful which power you are mentioning. Magnifying power is going to be 1 plus d by f. Now this d is the distant vision, the least distant vision, you can say. D is the least distance of distant vision. So if you're taking for normal eye, you're going to take 25 centimeters. It should be 25 centimeter. And small f means the focal length of the lens. Okay. So the technique is, if you want to increase the magnifying power, you just have to work on one part. You have to make the focal length very, very small. But it cannot have an infinite magnifying power. There is a limit to it, right? You cannot start saying very microscopic things like the microbes, microorganisms. You can't start seeing them, right? There is a limit to this, and But yes, to some extent you can increase. So you can just write the condition for increasing the magnifying power. I'm just writing P. You can reduce the focal length. Shorter the focal length, more will be the magnifying power. Yes, done writing, everyone. Let's quickly write the uses of microscope. Uses of simple microscope, which is called as the magnifying glass. First point you can write, used to read small letters. Second, used to read the scale accurately. Now the scale is the vernier scale particularly. I'm just writing V dot S. V dot S means vernier scale. Used by watchmakers. Wants to see all those tiny screws. Also used in traveling microscope. It's also used in spectrometer. So sometimes what they do is they may give you these instruments name and ask which type of lens is there. They may not directly ask, is it magnifying glass or what is it? They may ask you which type of lens is used in a spectrometer or a traveling microscope, simple microscope, or for reading small letters. So the name of the lens is convex lens. So few points we have already discussed when we have taken different situation, that which microscope is used in telescope, which microscope is used in the Galilean telescope. So there is a difference between these two terms. Galilean telescope use concave lens, and the regular terrestrial telescopes, they're going to use convex lens. So the name of the telescope is also very important that you're going to be considering. Magnifying glass, already we know it's convex lens. Spectrometer is convex lens. So this all terms will come under application based question on lenses. Now also the question, done writing, everyone? Yes, Anushka, Adit, Nidhi, finish writing.
Yes, ma'am.
Now our eyes, human eyes, naturally has a lens, and the type of lens present in the human eye is convex lens. Okay, and it tries to form an image which is going to be formed on the retina. So the image that is formed on the retina will be inverted image, and if it is inverted means they are real images. They're actually going to meet, and they should meet. If they're not meeting, there will be no image form. Later, through the optic nerves, when it is connected to the brain part, the images again made flipped. So the image formed on the retina is inverted. What is passed to the brain and processed, then that will be that means that it's going to be an erect image. Okay. So two things you're going to remember: eyes contain convex lens. That's a natural lens formed that is present in the eyes, and it forms an inverted image, and that image is formed on our retina. All these points are clear. Just write this information. I will see the defect based situation and which type of lens is suitable in which kind of defect. Yes. So we have different eye defects. Just have the idea of namings. So the first situation is myopia. Okay, we'll just read down. They're not going to ask you what is myopia, but unless in biology related a situation when you do human eye and all that, it's required. So, but just the information is by names you're going to see. And second is which kind of defect is it? Is it because you're not able to see objects which is kept at far distance, or the object which is kept at a near distance? Which vision is affected? That and the name of it. Myopia is a common name for impaired vision in which a person sees near objects clearly while distant objects, that means the far objects, appears to be blurred. So shortly you can say a person who can't see object which is kept at a far distance. He can see things, he or she can see the things which is near to, like he can read the books, read things, and everything is pretty clear when objects are close by. But let's say there is um, kind of a banner placed at a long distance, will not be able to see unless the images are very huge. The letters are very big, he'll be able to see. But if the letters are at an average size and kept at a far distance, even in the same room, will not be able to see those objects. Okay, so that is the defect based to myopia. In such a defective eye, the image of a distant object is formed in front of the retina. So wherever is the retina, the image will be formed in front of it. Okay, so it should have been on that red curve, but it forms in front. So you're not able to see it at all. So in such situation, consequently, a near-sighted person cannot focus clearly on an object farther away than the far point for the defective eye. This line is shortly to understand. Near-sighted person means this kind of problem is also called as nearsightedness. That means he can see the object which is close to him. So myopia is also termed as nearsightedness. You can write this down, everyone. Myopia is also called as nearsightedness. So every person will have 2 points. One is called as the near point and one is called as the far point. Okay. So there is a far point for a normal eye. We term that as infinity, does not mean like we can see at a very infinite place out of the galaxy, we can see it at a very far distance. No, we can see object which is kept at a distant infinite to our convex lens which is situated in our eyes. Now the question is kind of we can not see read things which is kept at a far beyond far point, but these people can see moon, these people can see the sun and few stars also. Now these are technically much at a far distance, but this is related to a term called as accommodation of power. Okay. So for normal eye, yes, we can see things as close as 25 centimeter and far. Till which position are you going to consider it for? You can see the sun, moon, and the stars, which is at a much far distance. But that is something related to accommodation. Your eye starts to adjust accordingly, whether you are seeing or viewing objects close to or viewing objects at a far distance. So for a normal eye, remember the near point is taken, the least distance is taken 25 centimeter, and the far point for a normal eye will be infinity, but does not mean that it will just go beyond a certain limit and you can see things which is not even in the periphery. Okay, when I say infinity, it is according to the lens that we have in our eyes. So this person who has myopia, also called as a nearsighted person, because he can see things which is near to him. He cannot focus clearly on an object farther away from the far point. So let's say 25 centimeter, he can definitely read because he does not have any problem with the near sightedness. That means that 25 centimeter vision is okay with him. But let's say for this person, 80 centimeter is the far point. Far point means up till 80 centimeter he is able to see. But beyond that, he is not able to see anything. It's something which is kept at a, let's say, when I say 80 centimeter, that means like even 1 meter is a far distance. And some object kept at a distance far that is beyond 80 centimeter. He will see it, but very blurry vision he will have. And if that blurriness is too much, then he is having more complexity. Okay, that is what is related to myopia. And this is how a myopic situation will be. There's some, you may see these kind of boards are available when you want to have a eye checkup done. They give you this kind of board where you see the topmost has a very bold bigger size, and as you keep descending, the size of the alphabets is going to go down. Okay, and the same thing is going to form an image. You can see the retina is actually here, but the image is formed before the retina. Okay, and it's inverted, correct? So he will be able to read maybe few of the first lines, but as descending the size becomes smaller, it's pretty blurred on the top portion, correct? So he'll not be able to read after a certain limit. So this is an eye structure of a myopic person, where is the image formed? Image is formed in front of the retina. Here is the retina portion. In front of it is the view. We'll just quickly read this causes and that, but that's not really asked. But we can just come into the correction part then. But let's read out the cause. So this defect arises because the power of the eye is too great due to the decrease in the focal length of the crystalline lens. So here is your lens. The eye lens is here, the natural lens of the eye. This may arise due to two reasons: excessive curvature of the cornea. You can always view such people will have a very bulgy eyes. Not necessary in all the cases, but this is viewed that they have too big curvature. Curvature is this portion of the eye that we're discussing. This portion of the eye. More the curvature and even the lens, more will be the focal distance. Shorter will be the focal distance. So curvature is big. That's one reason. Power is too much. Power is considered with the inverse relation with focal, correct? More the power, less the focal length. So that is the cause, that is the actual technical reason why a person will have this kind of defect. And second is the elongation of the eyeball. One is the one is, yes, the curvature of the cornea. So this is the cornea part, it's too bulged out. And one is the bigger structure, the bigger eyeballs that you say. That is the second reason related to myopia. And yes, after a certain age, everybody, no matter whether these two conditions are there or not, after a certain age, everybody will start losing the eyesight power. That means it will start becoming less. Now, what is the correction based to people who have myopia? This defect can be corrected by using a concave lens, that is also called as a diverging lens. A concave lens of appropriate power or focal length is being able to bring the image of the object back to the retina. So the only purpose is, here is the retina. Technically, image is formed, let's say, in front of the retina. We want this image to form exactly on the retina. So we want to push the image little backward. And how we are going to do that? We are going to be using a concave lens, which is also called as a diverging lens for the correction purpose. We will see that in a bit of time, but right now we just get the idea. The first defect we have discussed, it's called as myopia, called as nearsightedness. Some books might also be writing instead of nearsightedness, they're also writing short sightedness. That means they can view things which is in terms of short distance, that is close to them. And such people will be, you know, advised to wear spectacles, and these spectacles are going to be made of concave lens. Okay, so this is the first idea that we have understood. Now, second issue is hypermetropia, which is called as long sightedness, or you can also call that as far sightedness. That means this person will be able to see things which is far from a point, but he will not be able to see or read things which is kept close. That means maybe he will not be able to read the books or view the objects which is close to him. He will start having blurriness or having kind of strain on the eyes when he tries to read, especially for the reading things. So common names for the defect in vision, in which a person sees near objects with blurred vision while distant objects appear in sharp focus. Is pretty much okay seeing and viewing objects which is at a far distance. So in this case, what is the problem? The image is formed behind the retina. In case of myopia, it was in front of the retina, and here you can see where is the image gone. The image is gone much behind the retina. Then you will have to do just the opposite of it. You have to do something so that you bring the image in front, little shift it towards the retina. So you're just going to use an opposite lens, which is going to be a convex lens. To quickly read out the defect reason. The focal length of the eye lens is too large. Whatever reason you've seen for myopia, just the opposite reasons you're going to be considering here. The eyeballs become too short. There it was too bulgy, and here it is too short. So that the light enters from the nearby object cannot be brought to focus on the retina to give a distant image. Because the eyeball, they have said the overall structure of it is too short, that whatever light possible, see, our eyes are made up of convex lens, and it tries to take all the possible light so that it gets a proper image and forms a proper image. But because of this small structure of it, whatever lights it's trying to enter, it's not able to properly focus on it, and where it is getting focused, much behind the retina. For these two reasons, a person will have the kind of defect called as hypermetropia. So the correction is, this defect can be corrected by using a convex lens, which is called as a diverging lens of an appropriate focal length. Eyeglasses with converging lens supply the additional focusing power required for forming the image exactly on the retina. So the points that we have discussed for myopia, just the opposite points will be for hypermetropia. Now there is also a condition called as presbyopia. It's a combination, you can say. And a person, and this happens with aging, and sometimes people, it's not necessary with age, it can be due to some situation. A person can have this kind of problem even if he's becoming, it's not that old. So this problem is when a person will have both the issues. He can't see things near, and he can't see the things at a far distance. So the power of accommodation of eye usually decreases with aging. That adjustment, because when you are viewing things close by, your convex lens of the eye naturally becomes bulged or shorter accordingly. So that is called as power of accommodation of eye. And when you want to view an object which is at a far distance, it tries to expand or contract. So there is an expansion contraction with the help of some ciliary muscle. Like this is the lens and these are your supporting ciliary muscle. They will contract and they will relax depending. Sometimes your eye lens will look little thinner and sometimes it will look little bulged out. So this is a natural adjustment that our eye does, and this adjustment term is called as power of accommodation of eye. Now, with aging, ciliary muscles particularly will become very weak and very loose, and there will be a time that person will not be able to see things nearby, and not even things which is kept at a far distance. So for most people, the near point gradually recedes away, so they find difficult to see things that is nearby clearly without any corrective eye glasses. And then it arises due to, which we have already discussed, due to the weakening of the ciliary muscles and diminishing flexibility of the eye lens, because they both are connected to each other, and the lens flexibility and the ciliary muscles are not working with the age factor. So this kind of situation can happen. Okay. Now, this is a very different situation. That is, okay, now can you tell me, correction was not given here. Can you tell me what must be the correction lens for the case of presbyopia? Who can tell me that? That means this person does not have good vision for short, neither for long. So what kind of lens will be advised to a person who has presbyopia? Yes, Rachel, can you tell me that? Michelle?
Ma'am, will
Hmm.
it be both the lenses?
Correct. Because both the problems are there. Two lenses will be used, and shortly you will call that as a bifocal lens. Now, when I say bifocal, that means there are two focuses. That means there are two lenses. And here the two lenses, one will be a convex lens and the other will be the concave lens. Now, you must have, if there are elders in the family, there are spectacles these people are particularly advised. And you see there is a kind of a D shape at the lower part of the lens, whatever spectacles you're using, lower part of the lens. And this is a curved structure. So it's a convex lens which is present at the lower part. Okay. So convex lens for the reading purposes. And when they view things at a far distance, they are using this region, the top region. Okay. So the top region is used for viewing object at a far distance. So that will be the concave lens, and bottom one will be used for the reading purposes. So that will be the convex lens. Okay. So these are the combination of lens. Two lenses in the same spectacles will be there. So it's also called as the bifocal lens. Okay. So also remember this thing, like in that bifocal lens spectacles, which or the lower portion is which lens, the upper part is which lens, just know their names. Okay. Now the third situation is called as astigmatism. That is a kind of defect. Now, this is not a defect which is related to near or long sightedness. This is a defect which a person has and does not, the brain does not process the vertical vision or the horizontal vision. This kind is called as distorted vision. So, whatever objects is kept at the eye level, okay, and he's if he's not able to focus on one point, maybe let's say there is a television, there is a vase kept, and there is some photographs kept on the top. So if he's focusing on the television, these two objects which is kept, he's not able to focus on them very much. Like, we still know it's there in the background when we have a normal vision, but these people find it very difficult to coordinate the horizontal and the vertical vision. So the reason is specifically related to the curvature of the eye. So that is something that happens by birth. In most of the cases, it is by birth that this happens. So it's a defect in the outer curvature of the surface of eye that causes distorted vision. And in this situation, a person cannot simultaneously focus on both horizontal and vertical lines. So they have a different kind of vision which is formed, and very difficult to interpret what they are able to view. So this defect is usually due to the cornea that is not perfectly spherical. Now this is something that happens, as I've said, by birth. The correction can be that they can use eyeglasses with cylindrical lenses, and it will have a lot high power as compared to the remaining, oriented to compensate for the irregularities in the cornea. So only this lens is where we are discussing a different kind of lens. It's termed as a cylindrical lens. Just one case, if this is asked, only the name you should remember. They're not going to ask you the defect reasons or the part of it. But yes, convex lens and concave lens, that part, you need to know it very well about it, how it tries to help forming the image exactly on the retina. Okay, all the points are clear. Even the defects have been discussed and all the reasons of defect and what is the correction required, that is also covered up. Any doubt and any question regarding whatever we have completed so far? Yes. Let me just quickly ask one question from this. What is the maximum magnifying power of a convex lens? Magnifying power, magnifying glass is a convex lens, and this has a focal length of 5 centimeter. Calculate what is the magnifying power. First of all, you should know the formula. What is the formula of magnifying power? 1 plus b by whatever is the focal length given. It's for the normal situation. Tell me, how much will be the value? You can directly use because it's not related to diopters thing, correct? So here you can simply use the centimeter as it is because your distant vision that you're taking is 25 centimeters. So you can take focal length also 25 centimeter. There's no need to convert it into meter in this situation. Quickly calculate and tell me what is the value. 1 plus 25 by 5.
Mom, is it 6?
Yes, it is 6. Okay, and there has been this question that was asked in few papers, and just taking up that question. The question was asked, how are you going to differentiate between a concave and a convex lens? First situation, if you have been given a situation of distant object and one situation is printed page. With the use of these two, how you get to know that the lens that you're using is a convex lens or a concave lens? Situations are given to you. Here you have to differentiate between, uh, whether how the objects have been put. So very first situation is distant object. Okay. Now, if you are using, uh, like you are viewing a distant object, let's say we have a tree and there is this person viewing it, and he's been given a convex lens. Okay. So how he knows that, okay, this is a convex lens? What is the outcome of it if he's viewing a distant object? So for the case of convex lens, you just have to tell whether the image is upright or whether it is inverted. Yes, tell me, for convex lens, what's the situation? If it is a convex lens, then image will be inverted. So if he's viewing a distant object and he's able to see that object in an inverted manner, so it's clear he's using a convex lens. And if he's able to see the object as it is, upright, then he is using a concave lens. You can quickly write this down. This is case study based question, situation based question. They ask you just to for the knowledge checkup. So remember, inverted image is convex lens and erect image will be concave lens. Finish writing. Now, the second situation we have where we have a printed page. Okay, there is a content given to you, some terms are written, and they have given you lens. So if you're using a concave lens or you're using a convex lens, how you get to know? So if you bring this lens, let's say we have taken the convex lens, how will you see the image? Are you going to tell whether it's inverted or erect, or are you going to tell in terms of its size? For convex lens, how will be the size? Now I give that hint, magnifying glass uses convex lens. So how, if you take a magnifying glass, which is technically a convex lens, how will you see these letters? Yes, Adit.
I'm sorry, what was your question again?
If you use a convex lens, how will you see the letters which is been printed on the page?
Uh,
Okay, Anushka.
Ma'am, it will be like bigger.
Correct. So the term will be, it will be magnified. Okay. And on the same page, if you bring that convex lens, you will see the letters are going to be very diminished. So in case of concave lens, letters will be diminished. So these way also they can ask you questions related to concave convex lens. Okay, so this chapter is totally done. And as I said, next week there will be tests. So start preparing, particularly from this chapter up till the ray diagrams. Okay, and then tomorrow, next week, we'll also be starting off with spectrum. And tomorrow, we will continue with the maths lecture. Okay, and yes, keep practicing a lot of prism question again because that will be asked even in your final exams when you check. Prism questions are never skipped. It will be asked. There are many cases of prism that is put up in the paper. Okay, so after spectrum, as we have already discussed, once spectrum is completed, we'll come back to the prism based diagram questions. Because I can see there is a lot of confusion in the test paper that was given last week. Okay, so tomorrow at regular time for mathematics.